else is there to do on a wind day? Have we ever had a wind day before? Today, wind day number 1, 23 years of teaching. I'm on wind day. I'm going to drink some coffee today. Drink some coffee. There you go. Woohoo! You students are like so hyped. I know you are. Wind day. Who ever heard of a wind day? But man, it is windy. I was just looking out at the lake because I'm at the lake house now. Not that I'm just in this rental. But it's like you could go surfing out there if the water wasn't like 4 degrees. I ain't going. Anyway, here we go. 7.4. Oh, that's really ridiculous. Why did that come up like that? So 7.4, children. You know who I am. I'm Mr. Krause. This is Mr. Key for now. And I just want to remind you all, for those of you checking out my bids, things are now at www.mrkrausemath.com. I have no internet connection. I will get on there later, but we are at mrmath.com. All right, here we go. Yeah, let's just do this. Let's just go. Get her done. So, the unit circle. You know why we call it the unit circle? That's because, and it's very, very complicated, the radius equals 1. So this is 1, and this is 1, and this is 1, and this is 1. And you know what? If I drew 1 in here, you know what that'd be? That'd be 1. So the radius is equal to 1. We're going to center right here at the origin. So the center is 0, 0. So we're going to take some point P. Got the positive angles there. And point P has coordinates of A, comma, B. We're going to change that a little bit later. Make it a little bit cooler. By cooler, I just mean only math teachers been thinking it's cool, not you. It's a wind day. I'm at home. What else is there to do but drink coffee and make videos? All right, so let's talk about this. If we wanted to find, well, let's talk about the equation of this circle. The equation of this circle is x minus 0 squared plus y minus 0 squared equals 1 squared. Well, that's kind of boring. Isn't it really just x squared plus y squared equals 1 squared? Or just 1, excuse me, not 1 squared, which is 1. So, wait a second. Now, let's check this thing out. Let's go back to this little triangle. And let's draw a triangle in. I'm going to draw a right triangle in. Now, there's one of our right triangles. We know the radius is 1. Now, wait a second. If I was to get to this point A, B, wouldn't I go out here, A, and then I would go up here, B? So in order to get to that point A, B, I would have to travel that distance. Shoot. So in other words, this is B, and this is A, right? I mean, if I wanted to plot the point 1, 1, the point 1, 1 would be right there. Okay, we're the point A, B. So, whoa, crazy. Let me get rid of that because that's going to cause problems. All right, Maureen, let's go back. Maureen, hello, there you are. All right, so wait a second. Let's label this O, A, and H because we've done that before. This is the hypotenuse. If this is my angle theta, this is opposite, and this is adjacent. Okay, so let's see what we got here. The question says, what is the cosine of the angle in the diagram? Well, cosine, let's see, wait, first of all, some old horse caught another horse tripping on alligators. I think the Nooms uses Sokotoa. I don't. But we're going to use some old, so cosine of theta is equal to adjacent over hypotenuse. So this is equal to, let's see, the adjacent is A. So that would be A over the hypotenuse of 1, but that would just mean this is A. Okay. So then let's try sine of theta. Sine of theta would equal opposite over hypotenuse, and the opposite is just b over the hypotenuse, which is just 1. So this sine is just b. So in short then, cosine is equal to the x coordinate of the point on the unit circle. So then wouldn't the sine be the, and now we're going to use some ditto marks, y coordinate of the point on the unit circle? And then tangent, now wait a second. Tangent is equal to opposite over adjacent. So tangent would be equal to, so this was A, this is, let me write that a little bit differently. This is A. Now here comes the cool part. This is A, this is B, and then tangent would be opposite over adjacent. Wouldn't that be B over A? But wait a second. B is sine of theta, and A is cosine of theta. And you just learned your first identity that's going to be used in, oh yes, coming up in the near future, proofs that tangent of theta, and this is going to become a huge one, is equal to sine of theta over cosine theta. Commit this one to memory, children. It's coming. So using your picture above and your new facts about the unit circle, determine the values of the following things. So, wow, that's going to be tough to look at. Let me see if I can shrink this a little bit. So what we're talking about down here are all the points in red. So let me go, let's go back up to this thing and let's just figure out what all these points are. I want to do a little bit of work on this thing in degrees and radians and the such forth and such on. Let me see if I'm still recording. I'll be right back. If you're ever wondering what I do, by the way, I just stop it, make sure I save, because you got to save periodically, because I don't want to lose like 10 minutes worth of work and have to redo it. Plus, you know, need some coffee. So let's talk about the unit circle. We know this is 0 degrees. It's also 0 radians. This is 90 degrees. This is 180 degrees. We got the 0. This is 270 degrees. And this is 360 degrees. Now let's do it in radians. This is, wait, let's do it like this. How about blue? This is pi. This is actually 2 pi. It's either 0 radians or 2 pi. It's also 0 degrees or 360 degrees. So if this is pi, then that over there would be pi over 2. So this is 1 pi over 2, 2 pi over 2. That would make this one 3 pi over 2. Now let's go back and figure out what these points are. I'm going to write these points out. This point right here is the point 0, 1. This point over here is -1, 0. This point down here is 0, -1. And this point over here is 1, 0. Make sense? So now we can start talking about this. Come on, shrink for me, baby. Yeah, well, that's just ridiculous. Oh. Come on. It's taking longer just to find. Okay, there we go. All right, so the sine of 0 degrees. Now remember, sine is the y value. Sine is the y value. So the sine of 0 degrees would be right here. That's 0 degrees. Sine is the y value. So the sine of 0 is 0. The sine of 90, the y value at 90 degrees is 1. The sine of 180, 0. The sine of 270, -1. Let's do cosine. Cosine of 0, the x value, would be 1. Cosine of 90, 0. Cosine of 280, -1. Cosine of 270, 0. Just look and go along the points and pick out the x values. Now, tangent is a little bit different. Tangent is the ratio of sine over cosine. In other words, the y value over the x value. So we're going to do tangent of 0. That would be 0 over 1, which is just 0. Now we get a little funky cold Medina here. Tangent of 90 would be the y value 1 over the x value 0, and that is undefined. So the tangent of 90 degrees is undefined. And what we're going to find out when we graph this, at 90 degrees, we get an asymptote. Oh my God, can't touch those asymptotes. We're going to get asymptotes back. Yes, and we're going to do some cool graphing. All right, tangent of 180, that's over here. That would be 0 over -1. Who cares if it's -1? It's still 0. And the tangent of 270 is -1 over 0, but who cares? It's still undefined. Okay? That's the unit circle. Those are the cool points about the unit circle. All right. So let's blow this sucker up. Probably not something you should say. All right. So we're going to fill in the important feature of the unit circle below. So here, what we're going to start with is the points. 1, 0. 0, 1. -1, 0. 0, -1. 0, 90. 180. 270. 360. We're also going to go, this is pi. This is pi over 2. This is 3 pi over 2. Now, if you remember, we're going to cut these in halves. So there's half a pi. This is 2 pi over 2, or pi. This is 3 pi over 2, and this is 2 pi. All right, so I think we got it. Which functions are positive for angles in the, quadrant 1, quadrant 2, quadrant 3, quadrant 4? These are all the things that you now know and better start committing to memory because they are going to become incredibly important. Let me just tell you this one more thing. All students take calculus, and that's going to help you find out where things are positive. So for which angles terminating in quadrant 2 are positive? Well, positive is sine. So sine goes with cosecant. So there we go. There's the big winner. Which trigonometric function is positive for quadrant 4? Quadrant 4 is cosine. So that would be cosine and secant. In which quadrant does theta lie if tangent is, remember what I told you, kids, and this is an SAT trick as well. That does not mean less than 0. That means negative. Tangent is negative. Now here, this says cosecant is positive, but remember, that's the reciprocal function of sine. So in other words, they're really telling you that sine is positive. So where is sine positive, but tangent is negative? Well, that can't be in the first quadrant because everything is positive in the first quadrant. So I got to find out where sine is positive, but I can't use the first quadrant, and that would be quadrant 2. So the next one says, if sine, I'm down here at 16. I kind of want to try to use this drawing still. If sine is negative, remember that's what less than 0 means, and cotangent, I don't care about cotangent, I care about tangent. Tangent is positive. Which quadrant are we in? So sine is negative. If sine is negative, that puts us down here in these two quadrants right here. And now I want tangent positive, and this is where tangent is positive. So the big winner is quadrant 3. In which quadrants are tangent and cosecant negative? So you know what? Let's pretend like I don't have that drawing up there. And I just want to go, oh, all students take calculus. That's all positive. Sine and cosecant. Tangent and cotangent. Cosine and secant are positive. In which quadrants are tangent and cosecant? Cosecant goes with sine. So where is sine negative and tangent negative? And that would be, well, sine negative means I can't use these. Tangent negative means I can't use these. So that means there's the big winner. So, again, if we get this drawing, and you know what, kids get really confused by this, and I don't know why, right? This isn't saying sine of theta is negative 2/3. This is saying sine is negative. Well, hold on. All students take calculus. If sine is negative, then we can't be up here because all things are positive in the first quadrant and sine is positive in the second quadrant. Tangent is negative. Tangent is negative. Well, tangent's positive here, so once again, we are in quadrant 4. Believe it or not, these two questions are asking the same thing. Reference angles and the unit circle. Oh, my best friends. You know, so you know you're a math teacher when something like reference triangles and the unit circle are your best friends. Newman, get a life. Just kidding. In angles of 30, 45, and 60, we're going to use, remember, 1, square root of 3, and 2. Oh. Excuse me. If we're talking about angles of 30, 60, and 45 degrees, these angles, we want to use the reference triangles. If we're talking about 0, 90, we want to use the unit circle. So anytime I talk about these are called quadrantal angles, by the way. Not that you ever have to know that. They're called quadrantal angles. And the reason they're called that is because they lie on the in between quadrants. So they're called quadrantal angles. But they're all, so whenever I talk about the multiples of 90, 0, 90, 180, 270, 360, I want to use the unit circle. Otherwise, I want to use the reference triangles. And so these are the things that you now know. We know that this is the 30-degree angle because it's opposite the 1. This is the 60-degree angle. We know since these two are the same, this is 45 degrees and 45 degrees. And you know, notice my hypotenuse is 2. So these are the things that we're going to use, okay? So unit circle plus reference triangle equals what party is she cray-cray? All right, here's what we're going to do. We're going to take this reference triangle that we've had and we're going to dilate it by a factor of 1/2. Now, why do I know it's 1/2? Because we're going from 2 to a radius of 1. We want to get it inside of this. So our hypotenuse was 2. So now it's 1. So it's really 2 over 2. But if I dilate those by a 2, I got to dilate these by a 2. And so then that makes the coordinates of this point. Now that point is on the unit circle, right? The coordinates of that point are the square root of 2 over 2, comma the square root of 2 over 2. So in other words, I came out square root of 2 over 2, and I went up square root of 2 over 2. And that's that point right there. Well, remember, if you try to remember, that the x value is the cosine of theta. And the y value is the sine of theta. Well, what is theta in this case? That's 45 degrees. The cosine of 45 degrees is the square root of 2 over 2. And the sine of 45 degrees is the square root of 2 over 2. I feel a quiz coming on. You guys smell that? Quiz time. So that's the unit circle. That's the unit circle. And if we did this for, by the way, the unit circle, let's say we had our unit circle. We did the same thing, and we dilated it. So now we had, instead of 45 degrees, we had, let's say, 30 degrees. So we had this. And I had a 30-degree angle. Remember, this would be 2, this would be 1, and this would be the square root of 3. So if this was 30 degrees, and I dilated everything by a half, this would be 1. This distance here, which was 1, is now 1 divided by 2. And this distance here, which was the square root of 3, is now the square root of 3 over 2. So that means this coordinate would be 1/2 square root of 3 over 2. In other words, the cosine of 30 degrees is a half, and the sine of 30 degrees is the square root of 3 over 2. All right, let's go. So here's how we're going to do it. Find the exact value. So we're going to do 315 degrees. That's right here. Not right there. It's going to hit right in the middle of this thing. I'm having a devil of a time doing this. So 1 square root of 2 over 2, square root of 2 over 2. Remember, we dilated these to get to the unit circle, okay? Now, why did I know it was the square root of 2 over 2? First of all, oh my goodness. First of all, if it's 315 degrees, that makes a reference angle, and I should have talked about that, makes a reference angle of 45 degrees. Well, opposite the 45 degrees, we know is the square root of 2 and the square root of 2, but since we shrunk it to dilate it to the unit circle, it's the square root of 2 over 2. All right. Now, tangent of 315 degrees, God bless it, tangent of 315 degrees is equal to opposite, which is the square root of 2 over 2, over the adjacent, which is the square root of 2 over 2, which is just 1. Oh, that's pretty easy. Oh, wait a second. Wait a second. Let's back up the crazy train. What am I talking about? All students take calculus. We're not in this quadrant. And that, if I was in this quadrant, it would be positive 1, which means I must have labeled my triangle wrong slightly. Which one of these should be negative? Should this one be negative or should this one be negative? Right? Because going in this direction is positive, but going down is negative. So this should be negative. Negative and negative. All right. Whew, I'm glad I caught that. I know you guys caught it. What is this one? Can't see it. 120. So 120 is a little bit more than 90. Not quite halfway. So this is 120. That gives us a reference angle of 60 degrees. Now, 60 degrees. Let's see. That makes this 30. Now, my normal hypotenuse would be 2, but since I'm in the unit circle, it's going to be 1. Opposite the 30 is normally 1, but we're dilating it to shrink it to the unit circle, so we're going to divide by 2. Opposite the 60 is normally the square root of 3, but we're going to dilate it to the unit circle, and we're going to go by a half. So remember, this point right here is coming out 1/2 is the x value, and going up is the y value, square root of 3 over 2. Now, one of these should be negative because we're in the second quadrant. And yes, you were right, this one should be negative because we're coming out in this direction. So this one should be negative. So the question says, what is the sine of 120? Well, the sine of 120 is the y value. So the sine of 120 degrees is equal to the square root of 3 over 2. New York State loves to ask these seemingly difficult questions, but they're actually really, really simple. What are the fractions we know? What are the points on the unit circle that we know? We know 0 and 1, 1 and 0, 0 and -1, negative 1, and 0. And then anything with 1/2, square root of 3 over 2, and square root of 2 over the 2 is going to be a point on my unit circle. Now remember, 1/2 and square root of 3 over 2, those go with a 30, 60, 90 right triangle. If you see square root of 2, that's going to go with a 45, 45, 90 right triangle. So, as I look at this point that they give us right here, I see negative 1/2, negative 3/2. So that means we're going to be in the third quadrant. Why third? Because negative 1/2 goes this way, negative square root of 3 over 2 goes over there. So we're going to be somewhere over here. Let's go negative 1/2. That's right about, isn't negative 1/2 about right there? So that's this point right here. Negative 1/2, negative square root of 3 over 2. So let's draw that thing in. So this is negative 1/2, and this is square root of 3 over 2, but negative. So determine the exact value of all 6 trig functions. Okay, now since this point right here is here, we're in pretty great shape because this is cosine and this is sine. Correct? All right, so let's do this. Sine of theta and cosecant of theta. First thing I do is this. Cosine of theta, secant of theta. Put them together, group them, put them next to each other like this so you don't make silly mistakes like I was just about to do. Tangent of theta, cotangent of theta. All right, let's see. This one's easy. Let's start with cosine. Cosine is negative 1/2. So this would be negative 2 over 1 or just negative 2. Sine is negative square root of 3 over 2. So cosecant is negative 2 over the square root of 3. We have to multiply by the square root of 3 over the square root of 3, which is negative 2 square root of 3 over 3. And tangent is equal to the negative square root of 3 over 2 divided by negative 1/2. Well, that means to divide by a fraction, really what you want to do is you want to multiply by the reciprocal. Negative 2 over 1. These 2's cancel, and I end up with just negative square root of 3. Now, remember what we said before? We could always go back to the reference triangle. Once I recognize this is a 30, 60, 90 right triangle, I could go back to this where the hypotenuse is 2, the opposite of the, this is a 60-degree angle. So there's a 60-degree angle. So opposite of 60 is, and that's the angle we're actually talking about. So I should actually probably use that triangle. 2, 60 degrees. This would be the square root of 3. This would be 1. So tangent is the square root of 3 over 1. Tangent is opposite over adjacent. Remember, if this is my angle right here, opposite over adjacent. But another quick fact, if you've got 2 fractions, you're dividing one fraction by another, and the denominator is the same, you can just get rid of the denominators. So you end up with negative square root of 3 over negative 1, which is just, I said it was negative, right? It's just positive square root of 3. So this is just positive square root of 3. Now I know it's positive because all students take calculus. So tangent's also going to be positive, but tangent is negative 1/2 over negative square root of 3 over 2. And again, fun fact, let's get rid of the 2's. So I end up with 1 over the square root of 3. If you multiply both top and bottom by square root of 3, you get cotangent of square is the square root of 3 over 3. All right, let's try another one. Anytime I see these, it's 45 degrees. Now let's see what quadrant we're in. Negative square root of 2 over 2. Negative square root of 2 over 2. That's right here. Positive square root of 2 over 2. So negative square root of 2 over 2. Positive square root of 2 over 2. So let's write our 6 trig function, sine of. Now, by the way, If you ever want to know what angle that is, that's a 45-degree angle here. But that means this is 135 degrees. So what I'm really finding is the sine of 135 degrees. We're just going to call it theta for now. Sine of theta, cosine theta, tangent theta. Sine goes with cosecant of theta. Cosine goes with secant of theta, because remember, we hate students. We all hate the students. All right, there we go. All right, so sine of theta, if you remember correctly, is the y value. Cosine of theta is the x value. So sine of theta is the square root of 2 over 2. Cosine is negative square root of 2 over 2. Tangent is the y value, square root of 2 over 2, divided by the x value, which is negative square root of 2 over 2. Now again, you got the same thing over the same thing, so this is really just equal to negative 1. If I flip that, I also get negative 1. All right, now let's take the reciprocal of this. And hopefully your guys gotten good at this by now. This is 2 over the square root of 2. So I'm going to multiply by the square root of 2 over the square root of 2, which is 2 square root of 2 over 2, and the 2's cancel, and I end up with just square root of 2. So because I'm going to flip this one should be negative square root of 2, because it's the same math. All right, there we go. Any more? Please tell me there's more. Yes! Find the exact value of each. You and your partner should have the same answers. So what you need to do right now is go through all of these and do these. You're going to do these in class. So I'm going to pause the video. You should pause the video. And when you come back, I'm going to have all of the answers written in there. Okay? So I'm going to pause it right now, and then I'm going to come back and have all the answers written in there. Are you back? Because I realized I made a mistake. And I want to go back up to this thing right here, because I just made a mistake, because I was looking at something. I'm like, you know what? I made a mistake earlier. And I knew I made the mistake when I said it, but I didn't. And it was right here. I apologize profusely. The coordinates of that point are not 1/2 square root of 3 over 2. It's actually the square root of 3 over 2, comma 1/2, and that's because we're going out the square root of 3 over 2 and up 1/2. So this is not right. So the cosine of 30 is the square root of 3 over 2, and the sine of 30 is 1/2. All right, go back to what you were doing if you're not done already. If not, just scroll. Wait, it'll come. Okay, so for what I've done so far is I've put in all the easy ones, all the ones that are ones and negative ones, all the ones that are half and square root of 3 over 2. Let's see how you did. I mean, pause it if you need to pause it. This is negative 1/2. Oh, wait, this is not negative 1/2. This is just 1/2. Square root of 2 over 2. This one was a little weird because it was 405 degrees. But if you found the reference triangle, 405 degrees, we went, that's 360. And then we back into the first quadrant at 45 degrees. So really, this is the same as the sine of 45 degrees. But then the rest of them are kind of weird, so I want to take you through the rest of them. So let's talk about the cotangent of 270. That's not too bad. That's in the unit circle, right? Let's go down here to the unit circle. This is 0, -1. Remember, tangent is y over x, or sine over cosine. So that's tangent. So cotangent would be x over y, 0 over -1. So cotangent of 270 is just 0. Let's do cotangent of 360. Well, that's over here. Excuse me. That's 1, 0. And remember, tangent are the sine over cosine, or the y's over the x's. Remember, sine is y, cotangent's x, or cosine is x. So I want cotangent. So cotangent is going to be cosine over sine. Or in other words, 1 over 0. So that would be undefined. Cosine of 360. Where was it? Cotangent of 360 is undefined. So let's talk about cotangent of 180. Cotangent of 180 is basically the same problem. We got negative 1 comma 0. It's still going to be x over y, so that's negative 1 over 0. That's also undefined. Let's try to find the cotangent of 90. The cotangent of 90 is right here. That's 0, negative 1. Again, cotangent is going to be x over y, or 0 over negative 1, so that would be 0. Let's talk about the cotangent of 270. Oh, I did that one already. Oh. Okay, cotangent 270 we did. It's up there, 0. Let's do the tangent of 210. So 210 would be a reference angle that's 30 degrees. So it's really tangent of 30 degrees. So I'm going to go to my reference triangle. Tangent of 30 degrees. Remember, this is 30 degrees. So this would be opposite, this would be adjacent, and this is hypotenuse. Right, if I'm talking about this one, adjacent 1 over the square root of 3. So this is 1 over the square root of 3, which you know is the square root of 3 over 3. But then you got to think about, oh, wait a second, what quadrant are we in? We're in the third quadrant. All students take calculus. Okay, tangent's positive in the third quadrant. Okay, we're good with that. Now, cotangent of 240, that would be a reference angle of 60 degrees. So let's go back up to this one. Now we're going to talk about 60 degrees, but now we got to change our labels. Well, I could have left the hypotenuse there. This is opposite, and this is adjacent. So wait a second. I'm asking for cotangent of 60. So wait a second. Tangent is opposite over adjacent. Y's over x's. Sine over cosine. Something you got to get in your head. So cotangent is adjacent over opposite. X over y's. Cosine over sine. So I want adjacent over opposite. 1 over the square root of 3. In other words, the square root of 3 over 3. And since we're in the third quadrant, it's still positive. Cosecant of 135. Now, 135 has a reference angle of 45 degrees, and cosecant goes with sine. So let's see, back to 45 degrees. There's our 45 degree angle. Opposite, hypotenuse, adjacent. Sine is opposite over hypotenuse. So the sine of 45 degrees would be the square root of 2 over 2. So that would mean the cosecant of 45 degrees would be 2 over the square root of 2, which by now you ought to know is just the square root of 2. Now let's see what quadrant we're in. We're in quadrant 2, and sine is positive in that quadrant. So this is just the square root of 2. All right, we got 2 left. Tangent of 300. So the tangent of 300 has a reference angle of 60 degrees. So we got to go back up to the 60 degree angle. And we want tangent. Tangent is opposite over adjacent. Tangent of 60. Oh, it's already labeled for the 60 degree angle. So I should get rid of that. All right, opposite over adjacent is the square root of 3. So this is equal to the square root of 3. But I'm in quadrant 4, so that's negative. And finally, cotangent of 150. This has a reference angle of 30 degrees. So we got to go back up to this reference triangle. But now I want to label it for a 30 degree angle. So this would be opposite, and this would be adjacent. And let's see, what was I talking about? Tangent. So the tangent of 30 would be opposite over adjacent, 1 over the square root of 3. So the cotangent of 30 would be the square root of 3 over 1, or just the square root of 3. So this would be the square root of 3. Except I'm in the third quadrant, so that would, or the second quadrant, so that would be negative. So So almost all these are the same. I wonder if she kind of goofed on this one a little bit. Because otherwise, all the answers, whether you do the left side or do the right side, should all be the same, except number 39. And I think that's it, kids. There we go. There's the end of the day. Hopefully you did okay. Bye.